This is the video for Machine Learning Project 4. We are not going to be showing the pre-processing because that is the same as the last project. First, I'm going to be showing our genetic algorithm neural network trainer using the machine dataset. For all of our examples in the video, we are just going to do twofold cross-validation to save time. And so here I am going to run our experiment. We made a graph to visualize the convergence of our algorithm. It shows the average fitness value for all the networks in the population over the generations. Now, walking through the algorithm, the first thing we do is we initialize all the networks in our population. So we have 50 networks, and then we calculate all their fitness values. So here is one of the initialized networks, and then here is it calculating fitness values. This is done 50 times. And the next thing that we're going to do in our algorithm is we're going to select two parents. These are going to be with tournament select. So here are the first two parents, neural network right here, and then the second neural network right here. Then we perform crossover on the two parents. The crossover rate determined that the crossover happened. So here is the first child network that is crossed over, and then here is the second child network. And then we mutate each of the children. So here is the network that we're going to mutate, and then we have mutated it right here, and then we're mutating the second child, and then it is mutated again right here. Then we calculate the fitness for each of the children to be stored and used later on. Then we replace the networks in our list that have the lowest fitness values with these children. And then this step is repeated for our 1,000 generations. And so since it's steady state, it just does two parents for each generation. Here we have our final neural network that has the max fitness, and then that is used to test our data. So here's the predicted values, and then our actual values. And then after the second fold is done, it calculates the loss functions. In this part, I'm going to show us training neural networks using differential evolution. So I'm going to click Run. Here is the graph of the average fitness values over the generations. So you can see that it starts increasing and then eventually starts to converge right here. This is over 3,000 generations. And so moving through the algorithm, it's going to pick 4 different indexes from the network list. So first it's going to perform the differential evolution mutation on the 3 chosen networks. So that's going to be 17, 16, and 82. So these are the 3 networks that it's choosing right there. And then here is the mutated network that it does by using the differential evolution mutation. And then it does crossover on the original and mutated network. So here is the original, and then again the mutated network. And so it's going to cross them, and then the resulting child is created. And then we're going to calculate the fitness for that child, and then we're going to check if it has a better fitness than the original. And so here it says that it does not have a better fitness. And we are going to keep repeating this step until we have finished all of our 3,000 generations for this example. We just show the steps of walking through the algorithm for the first few generations, and then for the rest of the generations up to 3,000, we show just the max fitness. And so you can see that the max fitness increases here and then converges at this number. And then you can see that the final network that we run our testing on is right here. And then so that network is used to predict the values through the testing set, and then we're done with that fold. And then at the very end, you can see after the second fold is done, we have calculated our loss function values. In this part, I'm going to be showing our particle swarm optimization trainer. Here I'm going to run it. Here we have the graph of the average fitness values, and you can see it increases and then it plateaus out here. After initializing every particle, we also have to initialize the velocity networks. So that's what these are here. Then we update all the networks, and we go through by adding the velocity to the weight. So this is our initial weight, then we add the velocity, and then here's our updated network. And then we calculate the new fitness, and then we check if our fitness is greater than the global best fitness, and if it's greater than the personal best fitness, and if they were, then we would update them. And then we're going to calculate our new velocity, which contains our inertia component, our cognitive component, and then our social component. And then you add those all together to get your new velocity. And then this is repeated for all the other networks, and then that is repeated as many iterations as we have. As we go through the iterations, we see our max fitness value increases and then converges, and then it returns the global best network that it found, which is used to predict the values. And then once that is done, then we can calculate our loss function values.